A child in danger of drowning is being carried down to. Okay, so as you can see from, we are given that the child is in danger of drowning, which means the problem is already solved.
Thanks for the easy problem, Professor.
So anyways, these should be your givens. So yeah. So the problem is asking for which angle the boat needs to go in order to save the tax burden. I mean child. So it's represented here as theta, and yeah. We have two distance functions, which is the x of the child is 1500 meters, and the y of the child is 200 meters. So as you can see, these are only legs of a triangle of a triangle. Always assume this is right. Um, and then we're not looking for the hypotenuse. We're looking for the angle between the shore and the shore and the angle on where the child is. So yeah. In order to do that, you have to use your anime rules. Sokatoa Nani. So which parts of the anime move Sokatoa do you need to use? Well, you- you're not given a hypotenuse, so that that takes out sine, cosine, secant, and cosecant to since they all require the hypotenuse. So that leaves us with tangent and cotangent. So I mean, either one of the two works. You just have to put which leg is right. So remember, toa requires the opposite over the adjacent. The opposite in this case is 200 meters, and the adjacent is 1500 meters. So as you can see, I'm using tangent because it's easier and it complies with Soga Toa. Who cares about Chosha Kao? So anyways, you have to get either the tangent of 200 over 1500 or the cotangent of 1500 divided by 200. And but remember, put your degrees in degrees, no radians at this point. So that would mean I got 7.595 degrees. So yeah. So now that we have phi, we can now calculate the angle on which the boat needs to go in order to save the child. So we are given the 8 meters per second that the boat can go at an angle. So so first we have to split up that 8 meters per second vector into a vertical and a horizontal component. Uh, or I and j. So as you can see, for the vertical component we need 8 sine phi, which I got 1.06, and that and then and then we have to get the horizontal component by using the negative cosine phi times 8 meters per second. Uh, the reason why it's negative because it's going left instead of right, so it's negative. So it's going negative 8 cosine phi. But then we have to add 2 since the boat is going upstream instead of downstream. So you have to, you have to get what the boat can go at a calm water. Um, and then we have to like subtract it by 2 since there's current and the boat is going against it. So 8 cosine phi plus 2, 8 cosine phi is negative 7.93, and then we have to add 2 since it's the two forces going against each other. It would result in negative 5.93 meters per second. So now uh, so, remember these two components are vertical and horizontal. It's not the hypotenuse. So that would mean we have to use tangent theta, and then the tangent theta will equal the y component divided by the x component, since the y component will always be the opposite, since the whole problem is relative to the x-axis. So anyways, we're looking for the angle, so we can't just do it by just looking at tangent theta. We have we have to get we have to get the wait, hold up. We have to get the arctangent of of uh of this number, so in order to get theta, which and then when I calculated, I got 10 point degrees. So yeah, this is my answer. Hopefully your calculation is not in radians. If you like this video, please put a thumbs down and see you in the next one.